Alright guys, now I feel it's time for a worked example of what we've just gone through, and what better place to do it than from the comfort of my own house, the place that I like to refer to as Tom and Jerry's. Here's my housemate, Jerry.
Tom, what's that noise?
Is that the fire alarm?
I can rumba! Evacuate! Jerry, where are you going? It's this way! Go save the wiener dog! Oh, you idiots!
Okay, so what we can see in front of you right now is a question relating to the scenario we've just seen. The example is this. The table below shows the number of people n. That's excluding the wiener dog, by the way. Left inside Tom and Jerry's backpackers T minutes after the alarm goes off. Now here are the questions that it wants to answer, that it wants to ask. Show that the relationship is linear, find the gradient, find the rate of change, and express n as a function of t. Okay, so first of all, let's show that the relationship is linear. Alright, so to show that the relationship is linear, we need to basically just sketch a graph. Here's a axis that I prepared earlier. Feel like one of those cooking people. Now, basically what we're going to do is we're just going to go through and plot these points. Now, it may not have seemed like at the time, but there was actually at 0 minutes, so that's when the alarm went off, there was actually 140 people inside our building at that time. Then after 1 minute, 105 people. Then after 2 minutes, 70 people. Then after 3 minutes, 35 people. And then after 4 minutes, 0 people. Alright, to show that it's linear, basically all we now need to do is draw a line but going over all these points. And because it's a straight line, of course it is linear. Alright, well part B asks us to basically find the gradient. So we can do that using the rule m is equal to y2 minus y1 over x2 minus x1 that we saw earlier on in the year when we worked with linear functions. Okay, so basically to do that we just need to label, find our x1, our y1, our x2 and our y2, and that we can do by doing this. So we go x1, x2, y1, y2. Okay, so let's substitute those points in. Y2 being 105, Y1 being 140, X2 being 1, Y1 being 0. Okay, so 105 minus 140 is negative 35, 1 minus 0 is 1, therefore m is equal to negative 35. Therefore our gradient is equal to negative 35. Alright, now part C of the question asks us to find the rate of change. Now if you remember back to what I was talking about before, rate of change is equal to the gradient. So therefore, as we found before, rate of change is equal to negative 35 people per minute. Finally, the last question asks us to express n as a function of t. Well, there's a couple of ways we can go about this. If you remember back to linear equations, you have the form y is equal to mx plus c. Well, we're not actually dealing with y and x's anymore, we're dealing with n's and t's. So basically we have number of people is equal to mt plus c. Now where can we get this magic m and this t and this c from? Well, we can get it from what we've found before. We have n is equal to, now m was our gradient, which is equal to negative 35, as we found earlier, t, alright, and plus c. Well, c is our y-intercept. Now, if you look back at this part here, our y-intercept actually goes through 140. That is when t was equal to 0. Alright, also you can get it from here. So, basically, our c is 140. There is another way you can go through doing this. Let me just show you the 140, by the way. Alright, there is another way that we can go through doing this, and that is to use the rule y minus y1 equals m bracket x minus x1. Okay, this rule here came from the linear equations unit that we did earlier on in the year. Your y minus your y1, well, let's just use the y1 and x1 here. So y minus 140 is equal to m, well m, like I said, negative 35, bracket x minus x1, being our 0. Alright, y minus 140 is equal to negative 35x. Negative 35 times 0 is just 0. So therefore we get y is equal to negative 35x plus 140. But remember, of course, we're not dealing with y and x, we're actually dealing with n's and t's. So we've got number of people is equal to negative 35 times the amount of time that's been going plus 140.
Or some rates can actually change.
Okay, so up until now we've just been discussing constant rates, that is graphs that have just a straight line. For example, the number of people escaping from Tom and Jerry's after it started burning down. But not always do we deal with just straight line graphs, that is the new graphs. Sometimes we deal with functions that have curves, like quadratics. Alright, it's clear to see here that the gradient of this actually is changing all the way through. And sometimes we in fact deal with functions that have both curved lines and straight lines, so that is a hybrid function. Alright, so let's have a look at this graph and apply it to the following question on variable rates. So consider the graph shown for each interval, state whether the rate of change is constant or variable, and B, whether the rate of change is positive, negative or 0. Alright, so whenever I look at something like this for variable rates and try to determine, I like to imagine Walker Wally. Alright, now Walker Wally walks always from left to right along the axis. Okay, as he goes from here, if he's walking along and the graph is not a straight line, the rate of change is variable. So for example, here he's walking along and it starts off not too steep, but as he gets further and further along this point, Walker Wally is finding it really tough because it's becoming more steep. So therefore, A to B is a variable rate of change, and because he's walking uphill, it's positive. Okay, let's have a look at from B to C. Alright, so for here, it can be seen that Walker Wally will be walking along a straight line. Okay, so therefore the rate of change is constant because it has the same gradient the whole way. And once again, he's walking uphill, so it will be positive. Okay, for C to D, we can see once again that it is a straight line. So once again, for this from C to D, it is a constant rate of change. Because it is a straight line. Also, because it's a straight line, it's flat, so he's not walking up or downhill, it is a 0 gradient. Or a 0 rate of change. Right, and for D to C, he starts off here and he walks down. Now it's not too steep to start off with, but by the time he gets to this point here, Walker Wally is well and truly sliding down on his bomb because he can no longer stay up because it's too steep. So D to C is a variable rate of change because the gradient's changing. And because he's going downhill, it's a negative rate of change.
And there we go, guys. There we have it. It's the very end of our first lesson on rates of change. I hope you found it enjoying and relaxing learning about maths from the comfort of your own couch in your own home. I sure know that I was much more comfortable as I wore my pajamas and taught the content. I wish I could do it all the time, but the boss says no. Anyway, remember to tune into our next lesson, which will be on instantaneous rates of change. It'll be coming up straight after this. And remember, say hi to your maths teacher for me. Morty out.
This has been a Zebra Crossing production.